Alright, hi guys. This is a quick video on something called domain and range. And what I've already done, so if you want to pause the video, go for it, but I've already drawn a graph and kind of set us up here. This is a graph that we've been learning about in class. It's called a square root graph, the square root of x. You make a table and you plot a bunch of points and you graph this thing, and it's kind of this smooth curve. It's flattening out but heading up, and it looks like this. What domain and range is we're going to write a little note down here. It's a way of describing a graph. So I'm going to write a way to describe a graph. A way to describe a graph. And domain and range is a way to describe a graph, not using like words and sentences. I don't mean write a little paragraph about this graph like, oh, it's a really nice graph, it's going up to the right, it's smooth. Not that kind of description. What I mean is a mathematical way to describe a graph using numbers. So there's two pieces. There's something called a domain, and there's something called a range. So domain is referring to the x-axis. So studying the x-axis when I say domain. What are all the x values? And range is studying the y-axis. The y-axis. On a graph, when I look at the x-axis, I know the x-axis is the one going this direction, from left to right, right to left. So domain is kind of all the values from left to right. That's the x-axis. Range is on the y-axis, and the y-axis goes up and down. It's vertical. So for the range, it's up and down, or down and up and down. It's vertical. And so what we're going to do is we're going to look at a bunch of graphs, and we're going to describe the domain and range. So we're going to start with this graph up here. I want to write what's the domain equal, or what is the domain. So I'm going to leave a blank spot to write my answer, and I want to know what the range is for this graph. And every graph has a different domain and range depending on what it looks like. So let's work on this a little bit. Let's start with domain. Domain is the x values, the numbers going left and right. Do you notice how there's nothing going on this side of the graph? There's no negative numbers. It's blank over here. The first value that actually starts is right here at 0. So if I looked at the x numbers, the domain starts here at 0, and then the graph is going this direction. I'll draw a green arrow. So all the domain is it's all of these numbers that are going out towards the positives. So I would say that the smallest x number is 0. So x is getting greater than or equal to 0. Greater than or equal to because there's a point at 0, and then it goes this way. So at 1, 2, 3, 4, 5, 6, 7, 8, 9, there's values on this graph. If I went out to 100, I bet the square root of 100 is 10, so it would be up at 10 on the graph. I know there'll be a point there. The range is all the values going up and down. So we're looking at the y-axis. Do you notice that the graph has nothing down below? That the graph is only going up. So the range starts down here at the bottom and heads up on the y-axis. The range is all the positive y values. So I'm going to say that the range is y is greater than or equal to 0. And they just happen to match. The domain and range will not always match. But that describes my graph. It says that all the y values are positive and going up, and all the x values are positive. There's no negative numbers in this graph. There's my domain and range. Let me show you, this comes from a worksheet, but some other types of graphs. Like a circle. Let's look at this circle. I want to know what the domain and range is. And I could ask you, is this a function? And we should be able to answer. It's not a function because if I draw a line, the line hits at 2 spots. So is it a function? No. But I still can describe the domain and range. So let's start with domain. Domain is the x values. So I want to go to the graph and study the x values. Well, this circle has a small domain. It only goes from here to here. So on the x-axis, if I go down, look, it only goes from here to here. So if I drew like kind of a line, This domain does not go on forever and ever. I would say it goes between 3 and 7 down here. If I tried to go to 2, there's nothing going on here at 2, it's blank. Or 1, it's totally blank. So the domain is from 3 to 7. And what I want to do is I want to be able to write that mathematically. So mathematically, I would write x in the middle is sandwiched in the middle, and it's less than or equal to and less than or equal to. I call this a sandwich problem. It's sandwiched between 3 and 7. So 3 is less than or equal to x, which is less than or equal to 7. That means x is bigger than 3 and smaller than 7. So bigger than 3, smaller than 7, it's in the middle. The range is going to be kind of the same thing. If you look at the y values, here's the lowest point, here's the highest point on the graph. It goes in between here. So if I go over here, it goes from 1 up to 5. That's the tallest it gets. So if I asked you what the range is, you'd say, well, it's sandwiched in between 1 and 5. So you would write 1 and 5. And this is all the y values. So y gets sandwiched in the middle, and you write less than or equal to, less than or equal to. And there's my domain and range. The x values go from 3 to 7, and the y values go from 1 to 5. So let's look at something more normal. Circles, we don't see a lot of circles, but we see tons of lines. So here's some lines. Let's talk domain and range. Is it a function? Yeah, lines are functions. We've been studying them all year. But let's not worry about that. Let's worry about domain and range. Domain is all the x values, all these x numbers. So if I go to -1 and I go up to the graph, is there a point? Yeah. If I go to 1 and I go up to the graph, is there a point? Yeah. If I go to -3 and go up to the graph, is there a point? Doesn't look like it, but notice there's arrows here. The arrow means the graph just keeps going, keeps going, keeps going. So if I go up and I look for a point on the graph, I'd say, yeah, there totally is. Totally a point there. So yeah, and if I went out to like 4 and said, is there a point here? Well, think about it. The line's going to keep going down. So yeah, there's a point at 4. So is there ever a time when there's not going to be a point? No. All the x values, lines go on forever and ever and ever and ever. So the domain is all the x numbers, all real numbers. It's everything. There's nothing that it's not. The range is going to be kind of the same thing. Think about it. The range is all the y values. Well, think if the line keeps going up and up and up and up and up forever, then all of these y values it's going to go through. If the line keeps going down and down and down and down and down, then all of these y values down below. So again, it's all real numbers. And that's the way it's always going to be with lines. Like, look at this line. It's pointing a different direction, but it goes down forever and ever and up forever and ever. So all real numbers on the domain, it's going to have all the numbers, and all real numbers on the range. The line just keeps going forever and ever and ever. It's different with things like parabolas. We've studied a lot of parabolas this year. Here's a parabola problem. These are a little trickier. The domain, let's talk domain. Domain is all the x values. Well, if I go to -2 and I go up, I'm probably going to touch the parabola somewhere. And if I go to 2 here and go down, there's a point, and 4 here. Really, I'm pretty sure the domain is going to keep going forever and ever, because this parabola has arrows, and it just gets bigger and bigger and bigger, and it keeps going up this way, bigger and bigger and bigger. So if I go out to like -5, I bet if I went really, really high up on the graph, it would touch the parabola. So the domain is all real numbers. The range is not. The range is the y values. Parabolas have a low point. What's the lowest point this graph gets to? It's right here at -5. That's the lowest point. So if I went down here to -6 and -7, there's nothing down here. It's empty. So what's the range? Well, it's all numbers from -5 and up, going this way. So I would say that the range is y values that start at -5 and go up. So everything greater than or equal to -5. All numbers greater than or equal to -5. So here's 2 I want you to try. pause the video for a second and write the domain and range for these two graphs. Take a guess. Okay, we'll see if you got them right. So the domain on this thing is the x values. Now these are the x numbers. At 2 and 3 and 4 and 5, there's nothing out here. So the first x number starts at 1, and then it goes this way. It's all the smaller numbers. So the domain is x values less than or equal to 1, all the smaller less than values going this way. The range is all the y values going up and down. Well, since there's arrows and this is going to keep going, I would say the range is going to be all real numbers, because all the y values are going to be included. If I go down here to -5, it doesn't look like it's on the graph, but if I went this way, I think this parabola is just going to get bigger and bigger and bigger and bigger and eventually get down to -5. It'll just take a while. So all real numbers. On this graph, the domain, the x values, go all directions. It's going this way forever and this way forever, so the domain is all real numbers. But the range is not. The range is the up and down. And look, what is, if I go up, the highest point it gets to? Right here. This is the highest point at 2. And then everything's down below. So it's y values that are all below 2. So less than or equal to 2. Smaller than 2. And those are some examples of basically how you do domain.